line back here. We'll get 373 Kelvin times delta S equals 2,260 joules per gram. Then all we got to do is divide by 373K on both sides. And our delta S is going to equal, we need a calculator for this one, 2,260 divided by 373, about 6.06 joules per gram Kelvin. And that would be our answer. We got one more to go over. Would a reaction be spontaneous with an enthalpy, let's start writing this down, enthalpy of negative 75,900 joules, a delta S, so entropy of 138 joules per Kelvin at a temperature of 273 Kelvin. All we got to do is we got to plug it into that same equation right here. So let's just throw everything in there. We got delta G equals negative 75,900 joules minus 273 Kelvin times 138 joules per Kelvin. And let's put this in the calculator right here. 273 times 138. We get about 37,674. 37,674. And that would be in joules. So our delta G is going to be equal to negative 75,900 minus oops, what did I do? Negative 75, almost put positive there. So negative 75,900 minus 37,674. And we'll get a very large negative number. And remember, the sign is what is important here. So we'll get negative 113,574 joules. But remember, we're just worried about that negative sign right here. And if it is less than 0, so if it is negative, it is spontaneous. So we could say it is spontaneous, meaning that reaction will happen with no added energy. All right, so let's go through our answers for those of us looking at our answers at the end. We have number 1, energy can't be created or destroyed. Answer for number 2 right here. For 3, answer for 4. Take a look at our endo and exothermic answers. Our answers for our potential energy diagram, and our answers for entropy. And then lastly, we got our Gibbs free energy answers.